So how do you simplify square roots? In fact, I'm going to go to a fresh screen again. 6 root 150. So number 1, so this is 1.3. Number 1, 6 square root 150. Yeah, let's think about this. You guys know it, but you probably don't know that you know it. Let me show you. You all know what the square root of 9 is, huh? Square root of 9 is 3. And why? Like if a young child who didn't understand square roots was to ask you, why is the square root of 9 3? What would you say? Because 3 times 3 is 9. Exactly, right? It's just all about what number times itself is this thing, huh? How about, like, what's the square root of 25? 5. Because 5 times 5 is 25. Perfect. You know it. Now stop, back up, and think about what we just did. 25 is really 5 times 5, right? And what did the square root of 25 equal? 5. I just rewrote this by breaking up the 25. Okay, great. So what? Well, notice 2 5s inside the square root end up sending 1 5 out. And there's no more root. Right? Isn't that what we're doing when we say square root of 25 is 5? There really were 2 5s in here, huh? 25 was 2 5s multiplied. And the answer came out to be only 1 5 on the outside with no more root. Right. That's what we always do with roots. Maybe you've never stayed up late at night and thought, with roots.
You mean for like a, oh, no.
So let's go back and do the square root of 9 again.
Like 23 plus 2, was it square root of 23 plus 2?
No. I'm not getting that fancy yet. Just square root of 9 is 3. What is that 9 really? 2 3s. 3 times 3. And how many 3s came out?
1.
Only 1. In other words, it's a 2-for-1 deal. It's like shopping at Target and things are on sale 2 for 1. I have an analogy for everything. But if that helps you, it's a 2-for-1 deal. That's what roots do, don't they? 2 3s inside leads to 1 3 outside. 2 in, 1 out. Like when you're shopping and things are on sale 2 for 1. To buy 2, you pay for 1 going out of the store, right? 2 5s inside, square root of 25, is 1 5, isn't it? So square roots are really doing a 2-for-1 deal. And they are, and that's true. All right. Now, with that in mind, let's do that with this 150. So for something more difficult like 150, we're going to have to use our calculator and break it down. When a number ends with a 0 like that, do you know, I'm going to break it down like what times what's 150?
75.
There's a lot of things you could do. I like using the 10. But you're right, 75 times 2 and all kinds of other things. But I think it's just easy. When they end with a 0, just go, oh, it's 15 times 10. And then keep going. Got to keep breaking these guys down. A little factoring tree. You've seen this before?
5 and 2.
Yeah, 5 times 3 and 5 and 2. Right? Okay, so what? Well, let's clean it up a little bit. So this is 6 on the outside. And what's on the inside? 5. I'm going to put them in order. 5, 5, 3, 2. Kind of reorganize them there, right? You could check it on your calculator. You could take 5 times 5 times 3 times 2, and it would go back to become the 150, right?
I'm trying to figure out how you got that 5.
Just these guys.
Oh, I got you.
I'm just reordering them.
Yeah, I got it.
Yeah, good, right? So all we're doing is we're breaking down the number. I'm just taking the 150. Anything ending in 0 is 15 times 10. Break that down. Just kind of organized them. Now, how does stuff get outside of the root? Right, Target shopping, right? 2 5s in, it's a 2-for-1 deal, right? Yep. That's what we saw right over here. 2 5s in, 1 5 out, and they're gone. Right, just like over here. 2 5s in, 1 5 out, and there's no more root. Same rule, right? I'm not making up new rules. Just following the same rule. So out comes 1. What's that 5 going to do when he comes out there? Exactly what he was doing on the inside. What was he doing? Adding? He was multiplying. So he'll multiply. 5 times the 6 that's already out there waiting for him. 30 on the outside. Now what's left on the inside? 3 and 2. Just go ahead and re-multiply those because they can't come out. There's not 2 of them. 6, and we're done. That's how you simplify roots. It's a 2-for-1 deal. Have you seen that before? 2-for-1 deal. So square roots are fundamentally a 2-for-1 deal. 2 in, 1 out. All right. Well, if you got that down, I'll go to number 2. So
I haven't finished the pyramid yet.
square root of 48. Let's go on to number 2. This will be on YouTube if I'm moving along too rapidly. But I'm looking at that clock wanting to get through this material for you. Try square root of 48. Same kind of thing, simplified. So take your calculator and break that thing down. All right, so let's break down that 48. Just use your calculator. 6 times 8, if you're rusty on some of those times tables. 2 times 3, 2 times 4, and the 4 will break down further, right? 2 times 2. So what do we got then? We've got square root of anything that wouldn't go further. You tracking with me? So I just keep breaking down until I can't break down any further.
And then you clean it up, go 3 and then 2, 2, 2.
I think there's 4 2s, right? Yeah.
Yeah.
And it's good to double check it.
Yeah.
Just usually, what I would do if this was an exam and my exam grade was on the line, I would take my calculator and go 3 times 2 times 2 times 2 times 2 and hit equals. Make sure it's 48. Make sure you didn't accidentally drop something along the way, because it's easy to do that. And it'll tell you 48.
Oh, it's just the numbers underneath the...
It's the branches of the tree. How about that? It's the very ends. Yeah, it's not the 4, in other words, because he broke down further. Yeah, it's the final breakdown of everything. It's all the branches.
Oh,
Or it's all the...
I see what
I'm not saying that right, am I? It's the leaves at the end of the branches. It's the ends of the tree. Whatever you want to call that. The very ends, though. Yeah, don't stop midway. It's the very ends. But the main thing is to double check yourself. That'll just take you 2 seconds. Just go 3 times 2 times 2 times 2 times 2, and it'll be 48. And you go, all right, I got it. That's the DNA, if you want, of a 48. That's the breakdown of a 48, right? That's what makes a 48. Those are the prime numbers, if you're interested in the actual words, that make that 48. Anyway, so now what do we do? How do you simplify square roots? It's a 2-for-1 deal. So 2 2s in, 1 2 out, and they're gone. Another 2 2s in, another 2 out, and they're gone. And these guys will multiply on the outside, just like they were multiplying inside. So 2 times 2 is 4, and what's left on the inside?
2.
Just that extra 3. So one more time. 2-for-1 deal. 2 2s in, 1 2 out, 2 2s in, 1 2 out, and they're gone. Once they ship something out, they vanish. What's left over the only thing left on the inside is the 3.
So you multiply the ones outside?
Yeah, the ones that come outside multiply just like they were multiplying inside.
Okay.
No change there. Is that making sense? These aren't too bad. You can really get the hang of these. The power rules are hard, and there's a lot of different ones, but these are kind of the same every time. It's kind of nice.
Yeah, I never understood square roots. Yeah, I do.
All right, let's try another one. Let's see. Square root of 24 x to the 7th y to the... No, x 24 x 6 y 7. 4 x 6 y 7. So number 3. X to the 6 y to the 7 square root. All right, so same deal. It's 2-for-1 deal. Break down that 24. Break down that x. What does x to the 6 mean? Well, 6 x's, huh? Just write 6 x's. Break down the 24, write 6 x's and 7 y's, and do the 2-for-1 ship out. All right, let me jump in and help. 24, 4 times 6, 3 times 8, 2 times 12, whatever you want to do. It's all good. Just keep breaking down. It'll always end up being the same thing. It's its unique DNA stuff. 3 2s and a 3. It'll always break down to 3 2s and a 3. So 3 2s and a 3. You can double check it on your calculator. 2 times 2 times 2 times 3. It'd be 24. So that's the unique DNA of a 24. And then x to the 6, 1, 2, 3, 4, 5, 6. And y to the 7th, 1, 2, 3, 4, 5, 6, 7. We're not going to always write those all out. Once we've seen the pattern, we'll save some time. All right, but it didn't take too long. So now what do we do? 2-for-1. right? Ship out 2 for 1. So I circle 2 2s and ship 1 out, and they're both gone. It's 2 in for 1 out, and they vanish. Huh? Now, what about this 2 and 3 here?
No.
It's going to stay because there's not 2 2s. There's not 2 more 2s. There's not 2 3s. So they just stay. They're going to make a 6 again on the inside, aren't they?
And then you do the same thing with the 6s, right? I mean, the X's, right?
Yeah. So now these 2 X's,
Ship 1 out.
ship 1 out, and they're gone. These 2 X's,
Ship that out, too.
and they're gone. These 2 X's.
Ship that out.
So how many X's make it out?
3.
And how many are left on the inside?
None.
None. So what would have been a quick way to do that? Take the 6 and if you're going to Target and they have 6 whatever, 6 pair of scissors,
You subtract it from 6.
and they say, hey, the scissors are on sale
Or
today,
you divide it by
2 for 1,
You divide
and you
by
want to
2.
buy 6 of them. How many are you going to pay for?
Half of it, 50%.
Yeah. So if there's 6 scissors, you buy all 6 and they're on sale 2 for 1, how many scissors are you going to pay for?
Half.
3.
Or 3.
Right? So if we have 6 X's, how many are going to come out?
3.
Now let's do the same thing with the Y's. We have 7 Y's. So what if you're buying 7 items and they're on sale 2 for 1? Well, 7 items, we're going to have to leave 1 in, aren't we?
Yep.
When it's an odd number. So it's going to be Y to the 3rd makes it out, right? 1 Y from this, 1 Y from that, 1 Y from that.
And 1 Y will be in the square
And
root.
1 Y stays in along with the 6, right? This 6 right here, 2 times 3. And the Y, there it is. Is that making sense? You just got to be careful with the 2 for 1. So every 2 X's send 1 out, 2 X's, 1 out, 2 X's, 1 out. Same thing with the Y's, 2 X's. So really we just have to divide the powers in half, don't we?
Yeah.
And when it's odd, there's just 1 extra that's left in. If you want to save time. That makes sense? Because that's what a 2 for 1 sale does, right?
You're technically not doing math, you just simplify it.
That's a lot of math to simplify. Yeah. All right. Other questions I can answer on that one? These will make more and more sense as we practice. Let's try another one. So, because they're kind of very similar every time. Yeah. All right. Root of 121 x to the 48. All right. Let's do that one. 121 x to the 48. All right. Yeah, I wouldn't write out 48 x's. Try to save some time. And you might use your, if you don't know square root of 121, use your calculator. So if you just hit square root of 121, your calculator is just straight out 11.
Right.
So it'll just handle it for you. And now the x to the 48, we just take the 48 and we divide it by 2 because this means 48 x's, doesn't it?
Right.
And it's a 2 for 1 deal, so you pay for half of them, so divide it by 2, x to the 24. And the root is gone, huh?
Right.
Because there's nothing left over in the root, is there? Whereas the other ones, like this one, some of the stuff, like one of the extra y's and the 2 and the 3, they remained in the root and didn't come out. So we still had a root there in the final answer. But on this one, the square root of 121 is straight 11, and the 48 divides perfectly by 2, no more root. If there's nothing left in there, the root vanishes.
Right, if it was 49, then it wasn't a square root.
Exactly. There'd be a square root with 1 more left in. You've got it. See, roots aren't too bad, right? A little easier than all those power rules, I think.
So it would have been 11 square root of x.
11 x to the 24, square root of x, right?
Oh, that's funny.
All right, so b is the same. Oh, now they're going to go to 4th powers.
Yeah, that's what I got stopped on that.
Yeah, 4th root. 25 x cubed y squared, and then xy squared. Okay, x cubed y squared, and then xy squared. All right. 4th root of
So that means I'm behind.
x cubed y squared times 4th root of 25 xy squared. Okay. All right.
Does this need a whole page?
Maybe half. Depends how big you write. So So we've been, up to now, the square roots have all been 2-for-1 deals, haven't they? If they put a different number in the hook, like that 4, that just changes the deal. It actually sweetens the deal. It's going to be a 4-for-1 deal. That's what that does. The number in the hook, this is going to be a 4-for-1 deal at Target. So, now, what about the fact that we have 2 separate square roots? Doesn't matter at all. Just chunk all that stuff into one big root. There's nothing special about the 2 roots. I'm just going to make one big old 4. It's got to keep the 4, though, in the hook. We can't change the deal. It's still a 4-for-1 deal, you know. All right, now what's going to go in that root? Let's break everything down. So 25 is 5 times 5. The other 25 is also 5 times 5. So I'm just going to throw it all into the same root together. So how many total 5s do we have inside?
4.
4 of them. How many total x's do we have inside? We have 3 x's here and 1 more there. 4. I'll write 4. You can just write 4th power. Either way is fine. And how many total y's do we have inside?
4.
2 here and 2 there. 4 all together. Good so far? So far I've just kind of dumped everything into one big root. And now how does stuff get outside of the root? 4-for-1 deal, right? Your targeted things are on sale 4-for-1. So 4 5s in.
It would be 1 5 out.
1 5 out, and they are all gone, huh?
Yep.
And 4 x's in.
And that'll be
1 down. 4 y's in, 1 out. Now, is anything left over in the root?
No.
Nothing left over. So what does that mean the root does? It just vanishes, huh? So just 5xy on the outside, no more root.
Oh, that's funny. Yeah,
That's the answer.
Yeah, 'cause that's exactly how 5xy, they just...
Because there's nothing left in the root.
So you tricked me, so I have to put the whole thing in.
Is that making sense? It's a 4-for-1 deal.
What about when it's like 4 on the outside and another one is 30?
Yeah, then it couldn't come out. Oh, you mean if like the other root was a different
Yeah, the
number?
other was-
Oh, they won't do that. That'd be mean. Those would be crazy
On the
hard.
homework it did that.
Really? Which number?
It's like way into,
Different ones?
yeah.
Oh, I think that's something we'll live. Yeah, well, hopefully we'll get there. All right, yeah, but we won't have to do this kind of thing with that. I'll show you. Yeah, so there's another one. 16x squared, 2x cubed. 16x squared, 2x cubed, number 6. 16x squared, 2x cubed. Okay, a couple of 5th rooters. So you know the deal. Just chunk them all into one big square root, break them all down, and it's a 5-for-1 deal, isn't it? All right, let's take a look. So breaking it all down, let's make it one big old 5th root. Break down that 16. It's 4 times 4, and each of those is 2 times 2, 2 times 2.
Yep.
So we get 4 2s, and then the other one has a 2, which it contributes.
And all
So,
5 rules.
yeah, that's right. And then we have 2 x's here and 3 x's there. 5 x's.
Yep. There's 5 of those, and they cancel.
You could just multiply them, right, for 48 x to the 5th, and then break it down.
The 32, you mean?
32, yeah.
Yeah, right,
Yeah.
right. So 5 2's inside,
It makes 1.
1 2 outside, 5 x's inside.
Is out too.
And what's left inside the root?
Nothing.
So what does it do?
It goes away.
Goes away, 2x. It's a fancy way to say 2x. That means all of this is a fancy way of saying 2x. It simplifies that much. Is that good? Yeah. Yeah, good question. The 4 kept breaking down. Yeah, so you don't stop at the 4 because you only stop at things that can't break down further. Primes, we call them. Good question. Yeah, always keep breaking stuff down as far as you can. So we don't stop at the 4s. We keep breaking it all the way down. And each of those 4s broke into 2 2s. So that really is the 4 right there. It's the 2 2s. And this is the other 4. It's the 2 2s. So we're breaking the 16 down to as small a pieces as we can. His DNA identity. Does that make sense? 16 is made out of 4 times 4, yes. But each of those is made out of 2 2s. Like say, like I'm made out of flesh and blood. Yeah, but then break it down. My flesh and blood is made out of DNA, right? So same kind of thing. We're just breaking the 16 down as far as it'll go to his little bitty pieces. All right. So back you go. That was 16. Oh, no, that wasn't 16. That was 6, wasn't it? I'm dreaming. We're not that far yet. Okay, and we're going to add them. That'll be easy. 15 root x, 18 root x. Okay, number 7. Piece of cake there. 15 root x plus 8 root x. Like that. So now, notice we're switching gears a little bit. This will actually be easier. We're adding roots. We're not multiplying them. This is right. Look back at the last problem. See, these were timesed. They were the last problem. They're multiplied. Now we're adding them. It's a simple rule. Adding square roots is just like roots. Treat them like, in other words, add the numbers in the front on the like roots. Don't change the roots, the square roots. It's all about like roots. So in other words, it's just like doing like terms. So 15 roots of x and 8 roots of x added together. Just use your calculator, add them up. Whatever 15 plus 8 is, 23. And then you just keep the root x, no change. So it's exactly like adding normal x's, right? What would we do with 15x plus 8x, just normal, no roots? It'd be 23. And we wouldn't make it x squared or do anything funny with the x, would we? We would just keep it plain x because they're like terms. It's exactly the same for roots. You just do like terms. Just add the numbers in the front. All right, so that's number. But remember, that was adding. That was adding. So 18, ooh, then we're going to divide them. Look at that one. That's a big one. Okay, x to the 11th, y to the 8th. 11, 8, 5, 2. 11, 8, 5, 2. 11, 8, 5, 2. And that was that a 6th root?
Yeah.
On both of them, right? Yeah. Okay. So we have these 2 6th roots of x divided. Remember what we did a minute ago when we had 2 roots multiplied? I'll go back for just a second. I'll be back to this. It's okay if you haven't got it copied yet. What did we do right here when we had those 2 roots multiplied? We just made it one big old root. We don't need 2 of them. Same thing here. Just make it one big old 6th root. And you don't need 2 of them. It doesn't add anything to it. Just put them all together in one big old root. Don't need 2 of them. So just like the multiplied or divided, whatever, just make it one big old root and just throw everything in there. It's all good. Now, we learned in the last section, our first hour together, how to simplify that inside, huh? Can you simplify that inside first? Remember what we learned? When we have powers that are vertical up and down like that? Subtract them, huh? Yeah, and you start with the bigger one, which is on the top, so the answers will be on the top. The bottoms are going to vanish, aren't they? Because they're the smaller ones. So 11 minus 5 and 8 minus 2. And so what's going to happen here? Yeah. If you're not 100% sure, go ahead and write them out. It's going to be 6 x's and 6 y's. And 6. It's a 6 for 1 deal, isn't it? 6 x's in, 1 x out, 6 y's in, 1 y out. What's left inside the roots? Nothing. So that vanishes. It's just xy. That means all of this is a fancy way to say xy. It really simplifies. All right. Not too bad, right? Let's see. So number 9.
Hold on, I think I messed up.
10 root of 18, 5 root 50. 10
Oh,
root
yeah.
of 18, 5 root 50.
I know what I did wrong. I made 60.
5 root 50. 10 root 18, 5 root 50. 10 root 18 plus 5 root 50. Okay. So how about this one? Now notice this is adding, huh? Not multiplying or dividing. You got to we can get so focused on the roots. You got to remember what we're doing. And they've just changed the game a little bit. We're adding again. We're adding roots. And so what's the deal for adding is different than dividing or multiplying in the root rules. Back over here we were dividing. Back over here we were adding. What's the rule for adding? Add like roots. So if the roots match, add them. In other words, here, let me be more clear on that. So if you had 7 root x and you tried to add to it, I don't know what that is, 2 root y, you could not add them because they're different. They'd be unlike terms, just leave it. Whereas if they were both root x, you could add them and it'd be 9 root x. Oh. Making sense? So you got to have roots that match. Do these roots match?
Yes.
No.
No. The items inside the roots are not the same. They're not like each other. But they're not yet simplified. Send out their pairs. Do the 2 for 1 on them. Oh, by the way, this 10 is not in the hook. It's just in the front. See the difference? It's not a 10 like there.
Like the other one.
Yeah, so this is just a normal 2 for 1 roots. These are just normal 2 for 1s. Those numbers are in the front. They're not in the hook. You tracking with me? So these are just normal 2 for 1. So let's just take this 18 and break it down. 2 times 9. 9 is 3 times 3.
2, 3, 3.
So I'll rewrite what do we have here. We have a 10 root of 2, 3, 3x. Good so far?
The 5 in the root or just
5 is the same one.
Yeah, neither 5 is in the hook. There's no numbers in hooks anywhere.
No, 25.
So then break down the 50. 5 times 10, that's 5 times 2. So bring down the 5 that's in the outside. And then what's on the inside? 5, 5, 2, and x.
And take away 2, 5.
You can put them in any order.
Kick 1 out.
Yeah, so both these roots are 2 for 1 because there's no numbers in the hooks. So 2 3's in, 1 3 out, and they're gone. What's that 3 going to do when it comes to the outside?
Still go away.
It's going to times what's already out there. So it'll be 30. Right? That's what we did way back in the beginning. Back here on number 1. Remember? We had that 6 already out there. And it came out and multiplied what was already out there. So 30. What's left inside the root?
The 2 and the x.
2 and x. Okay. Now what happens with this one?
Same thing. You kick out the 5.
Yeah, 2 5's in, kicks 1 5 out, and there's something out there waiting for it. And multiply 25. What's left in the root?
2x.
And now I ask again, are they like roots? Now they are. Once they're simplified. Now we can add them, yeah. So now 30 and 25 makes 50. What do you do with the root? Nothing at all. You just keep it as it is. These are like roots. Their roots match exactly. So once you've got like roots, you just add the numbers in the front. But you have to go through all that simplifying first. How we doing? You got a good 15 minutes in you? We don't want a bad 15 minutes. We got to get some good stuff done here. Is that good?
Yeah.
Still able to hear me talk math at you? All right, so that was number 9. And so 10, same thing, I guess. 8 root 63, 4 root 7. Yeah, I think I'm going to move on to some harder ones. Yeah, I'm going to try to... I want to try to get to the ones that are more difficult. Ooh, okay. We could do that one. Okay. Sounds good. So it's just big and messy. So 32, x to the 6th, y to the 11th. I can't remember all this. So, biggest problem of the night, I think. All right, yeah, so first make the observation that's being made up here. The middle root is a 4 in the hook. The other two have nothing in the hook, so they're 2-for-1 deals, aren't they? So they are oil and water. They're not going to mix. The one in the middle is totally different from the ones on the outside. The ones on the outside will probably end up being like terms, I bet. Just know how they write these problems, you know. But the one in the middle is never going to combine with them because he's a different number in the hook. He's a different animal altogether. So we'll see it go. All right, here we go. Let's break down the 32. Just use your calculator. I'm going to save some time because we don't have much time left. 2 times 2, if you break down the 8, 2 times 4, another 2 times 2. So 5 2s there.
So basically what you're saying is, don't panic, just follow your formula.
Yeah, it'll work. Yeah, just the normal steps will work. 5 2s, x to the 6th, y to the 11th. Minus. And then in the middle, well, we don't need to do anything. That's the only number we really needed to break down, huh? The other ones just have tiny numbers, just 2s in there. All right, so I'll just do that. Now, let's do this first root. So what the first root, there's no number in the hook. So how are we going to, what's the deal in target?
2
2
for
for
1.
1. By the way, if you want names now to help, remember, what do we call this root? We call it a what root?
The hook.
Square root,
Square
right?
root, yeah.
What does square mean?
2.
Yeah. What do we call this? X twoed? X squared. Right? What do we call this? Cube. Square and cube, right? Square is flat, 2-dimensional. Cube is 3-dimensional. Square and cube are shorthand words for 2 and 3, aren't they? So no wonder we call this root a what? Square root. Because what kind of deal is it really? 2-for-1 deal. That's why we call it a square. There's really an invisible 2 there. That's what it is. You don't have to write the 2. But that's why we call it a square root. Because it's really a 2 root. It's a 2-for-1 deal. That's why it's called square root. Whenever you say square, you're saying 2. When you say cube, you're saying 3 in the math language, right? So, yeah, that's a square root. It's a 2 root. There's really an invisible 2. Just over time, they used the 2 roots so much that they started saying, look, if I don't write anything in the root, I mean a 2. That's just kind of how it happened over time, like any field. All right, so there's really a 2 there. It's called a square root, and it's 2-for-1 deal. I'll get rid of it just so it doesn't look confusing. All right, so it's a 2-for-1 deal. 2 2s in, 1 2 out, another 2 2s in, another 2 out. Now, so that's 4, on the outside 4.
Then you get have 3 X's.
Yeah, then what about 3 X's? We good? Because 6 X's in,
There's 3 out.
right? You're paying for half of them, right? And now what about the Y's?
The Y will be 5 Y's.
Yeah, the easy way to deal with that, I think, is to make it y to the 10th and 1 more. That's 11, huh? Just make it the even number. I think it'd be easy. Because, if there's 10 items and it's 2-for-1 sale, you're paying for 5, huh? So y to the 5th will come out. And what's left inside?
Will be 1 Y.
We got this 2 and 1 y. 2 and y, huh? Got that leftover 2 and that leftover y, don't we? That couldn't come out. Good so far?
Yeah.
Good on the left root? Let's go to the one in the middle. What kind of deal is the one in the middle? 4-for-1 deal. I would suggest just writing the X's. It's not going to be that painful. 1, 2, 3, 4. I'm going to write them in groups of 4. 5, 6, 7, 8, 9, 10, 11, 12. It's a 4-for-1 deal. So what's going to happen? 4 X's, 4 X's, 4 X's. There's my 12 X's. So each of those will send 1 out, won't they? 4-for-1 deal. So we got 5 that's already waiting on the outside. X cubed. Good so far? Now what about the Y's? Well,
Same thing.
got a bunch of them, yeah. Same ugly thing, huh?
But since you already know, you can divide that into 4.
Yeah, if you're catching on, you divide by the number. That's really what it is. But in case you're not sure, I'll just write them out. I'm going to write them out in groups of 4. 2, 3, 4 Y's. 1, well, I'm running out of room here, huh? I don't know where to write them. Yeah, I really don't. I'm going to erase these X's. I'm going to write the Y's right below them. So 1, 2, 3, 4 Y's. 1, 2, 3, 4 Y's. 1, 2, 3, 4 Y's. 1, 2, 3, 4. How many is that? Oh, and one more. There's 21 Ys. 4 times 5 is 21.
Yep.
5 groups of 4.
Yep.
And it's a 4 for 1 deal. So these 4 send 1 out. These 4, these 4, these 4, these 4. So how many Ys come out? Y to the 5th. How many are left inside? 1 Y. And that leftover 2. Don't forget about him.
Yeah.
It's easy to forget. There's such a mess here, huh? And don't forget to put that 4 back in the hook. Whatever number's in the hook will never leave. That's the deal. It has to stay there.
Okay. So you can remember what you were doing.
Yeah. And you got to type it in for the final answer that way, or it'll mark you wrong. And you'll be like, what? What's the problem? And it's the 4. It wants the 4 in that hook. All right, now, before we use up the whole night, let's go finish this last one over here. Now, this is 4 X's. And it's nothing's in the hook on this one, so it's a 2 for 1 deal. 2 X's in, sends 1 X out to hit that X that's already out there waiting for it. And the other 2 X's send another X out. So we have 1 X out, another X out, and one that was already out. So that's going to be 3X to the 3rd. And then how many Y's are coming out? Well, we got 9 of them. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 Y's, 2 Y's, 2 Y's, 2 Y's. A 2 for 1 deal.
Will be 1 Y left.
Right. 4 coming out, and there's the 1 that was already out there. So that's 5 out altogether. How many are left inside? 1 Y and that 2 that was already in there. What a mess, huh? All right. So where are we at? We got this, this, and this. Now, these guys are like terms, and the middle one is different. So he will not combine with them. But see how these two have the exact same letter and root pattern. X to the 3rd, Y to the 5th, root of 2Y. X to the 3rd, Y to the 5th, root of 2Y. 4 of them big ugly things, and 3 more of them big ugly things. What do we got? 7 of them big ugly things, right? 4 of them and 3 of them. So 7 of those X to the 3rd, Y to the 5th, root 2Y things, minus, and then the other one, just bring it down. He's not going to combine with anybody. He's a different animal altogether. And don't forget about his 4 that's in the hook. That's, oh yeah, because you might have thought he would combine, because he looks similar, huh? X to the 3rd, Y to the 5th. They're trying to fool you. But that 4 in the hook makes him different. So he has to stay separate. He's not a like term. And so that's it. The front one and the back one combined, and the middle one stayed separate because he had a different number in the hook. That's a rough problem they made up there.
Is it going to be on the...
There'll be 7 of those on the exam. No, I don't know.
So when we were doing these, when we were actually getting it right, we were just going off. Because, just like you said, she followed the same stuff.
Right. All right, we got a few minutes. I want to use every second for your advantage. Let's see here. How we doing? What number was that one? 13.
I'd rather work on the
Ooh, I'm not going to simplify that one. Oh, 15. Let's go to 15. How many we got left? Let's see what we can do. Yeah, so let's do 15. 10 over root 2 for number 15. 10 over root 2. All right, I'm going to skip to 15. 10 over root 2. All right. Well, what they're going to basically say to us, I don't know if you've seen it before, but you never leave roots in the bottom of a fraction. So we never leave roots in the bottom of a fraction. Well, then what do we do with it? We got to get rid of it. Anybody seen this before? Know how you get rid of roots from the bottom of a fraction? So when there's a root in the denom, you multiply top and bottom by that root. You multiply the top and the bottom by that root. So you come in here and you multiply root 2 on the top and root 2 on the bottom. Now, why are we doing the top and the bottom?
Because what you do on the bottom, you have to do on the
Yeah, so you don't change anything, huh? So we're not going to change the value. We're just going to change the look. All right, here we go. So just multiply straight. 10 times root 2. 10 root 2. On the bottom, root 2 times root 2. Root 4. Good so far? I'm timesing, right? I'm timesing. 2 times 2 is 4 down there. Is that good so far? Now, what is the square root of 4? Yeah, that becomes plain 2, doesn't it? Square root of 4 is just plain 2, and the root vanishes. We good there? Yeah. That's different than just the root of a 2, isn't it? Root of 4 is plain 2.
Yeah. So you do 2 and 2, you kick out the 1.
Right. Or you could do 2 2s and 1 kicks out, for sure. Okay, now can we do more? Yeah. Can I cancel 2 into 10? For sure. They're both outsiders. Right? As long outsiders can go with outsiders and insiders with insiders. Stuff outside of the root can interact, so it's totally good. So the answer is 5 root 2. What did we do? We took that right there and we got rid of the root from the bottom. We never want to leave roots in the bottom of a fraction. Does that make sense? No roots in the bottom of a fraction. Let's try one of those and we'll call it a night. Let's see what they have for us. 30 over 7 root 6. That's beautiful. 30 over 7 root 6.
So technically that one, we're supposed to really eyeball that one.
30 over 7 root 6. What's that, Dennis?
We were supposed to eyeball that one. The 5 over 2. Because if you simplify the 5 over 2, I mean the...
Oh, the 10 over 2. Yeah, you're supposed to just see that 10 divides by 2. Yeah, for sure. You're right. That's right. You can just see it. Yep. All right, let's try that one. So we can't leave the root in the bottom. Got to get rid of that root 6. So what are you going to do to get rid of that root 6? Yeah, what does it say right here? You multiply the top and the bottom by that root. So multiply top and bottom by whatever that root is. So whenever they give you a root in the bottom, you multiply top by, what's that? It's just the, you good there? That's 7 root, can you read my writing? 7 root 6 here. Like that. So whenever you have a root in the bottom, you multiply the top and the bottom by that root. Now the rule is outsiders multiply outsiders and insiders multiply insiders. So in other words, we're going to get 30 root 6 on the top. What's going to happen on the bottom? Who's going to multiply? These two are going to multiply because they're both insiders, huh? Insiders multiply insiders. So that's root 36. So far, so good. See what's happening there? Outsiders multiply outside. Outsiders stay outside, and insiders multiply with insiders. Now, what is the square root of 36? It's just plain 6. In fact, if you want to save time, and I'm sure you want to save time, whenever you have 2 of the same root multiplying each other, that means 2 6s, and the whole thing's a 2-for-1 deal. So of course 1 6 is going to come out, huh? Did you track with that? So in other words, what is root 6 times root 6 always going to be? 1 plain 6, because 2 6s in, send 1 6 out. What is root 5 times root 5 going to be? 1 plain 5, because 2 5s in, 1 5 out. What's root 11 times root 11 going to be? 1, because 2 in, 1 out. So right here, root 6, I could just make that a plain 6 with no more root. Now, I wrote root 36, but that is plain 6, isn't it? See how it's the same thing? And this just saves time for us. So whenever you have 2 of the same root, it's just one of those out plain. Okay, so what? Well, then that's 30 root 6, and the bottom is 42. Right? Because they're just plain old numbers now, no more roots. It came out of the root, right? And then can you simplify 30 and 42? What goes into both those? 6, yeah, divide by 6. Top and bottom, that'll be 5 root 6 over 7. There we go. That fraction is as simplified as it can be. All right, well,